Hi, my name is Guang, I'm 12 years old. For this lesson, we're continuing on with the techniques and applications for definite integration. For this lesson, we have another two examples. So over here, let's first look at the examples. So for our first example, we have integral from 0 to 8, integral from cubic root y to 2, square root x to the power of 4 plus 1 dx dy. Well, for our second example, we have double integration d 5x cubed cosine y cubed dx dy. D is bounded by x is bigger or equals to 0, y is equals to 1 over 4x squared, y is equals to 2, and the y-axis. Okay. So let's start with our first question. So why don't we first draw the diagram for our first question. So over here we'll have So what we'll have here is, so over here x is equals to square root y, to x is equals to 2. So x is equal to square root y. Over here, what will it be? I mean cubic root y. So over here it's going to be and this is for the x is equals to cubic root y, and then x is equals to 2. It's simply just and the 2 mark over here. Then for y, it is from 0 to 8, so it only makes sense for this part. This is going to be 8 because that x being 2 is the cubic root 8 is 2. Okay. So over here, don't mind the sign. Whoops. So this is 8 and this is 2, okay? And now we can integrate for this part, but we're going to integrate with respect to y first, because that for this part, we'll integrate with respect to x first. You cannot solve it for this at the x to the power of 4 plus 1 square root. Well, if you integrate to y first, you have to change the boundary. So over here, the y will be, so over here, what's the area bounded? So the area bounded will be over here for this part from this to 2, and then from 0 to 8. Basically this part, okay? And then after, so in order to change the boundary over here, we will have to look at y first. So it will be from 0 to this function. So x is equal to cubic root y, right? So y is equal to x cubed. Then what about for x? X is basically from 0 to 2. So when we integrate with respect to y first, we're going to get a and now we can substitute the boundary inside, and we will get, so when we substitute the boundary inside, we'll get from 0 to 2 x cubed, and then this will be here having the same thing, x to the power of 4 plus 1 dx. Then after that we'll have, so we can put this inside, which once you integrate is going to be x to the power of 4 over 4, which we're going to end up with Well, the reason why we can straight away plus 1 is because they're adding a constant. If we look back over here, once you differentiate it, it becomes 0. Okay. So for this part, over here, what we're going to have on this part, we can already straight away integrate it. So it's basically dx, square root x dx, the integration. Okay. So square root this part, basically this part to the power of 1 over 2, right? Which means that once you integrate it, it will become to the power of 3 over 2, right? And then when you integrate it, you also have your 2 over 3 outside from 0 to 2, and we can substitute this inside, and these two simplify. This becomes 2, and then this part, when you substitute this part in, you're going to get 1 over 6 times, so 2 to the power of 4 is basically 16 plus 1, so this part is basically 17 square root 17 over here. Well, for the other part, we're going to have for this part, when you substitute 0 inside, it's just going to be 1, so it's just going to be 1 over 6. Okay, and this is the result we get, 17 square root 17 over 6 minus 1 over 6. Okay, so for this example, what we mainly did was just to change which one we integrate with respect to, because then we cannot integrate with respect to x plus, so we'll have to integrate with respect to y first, and the rest are just basic integration. And now moving on to the next example, what we'll have here is double integration d5x cubed cosine y cubed dx dy. D is bounded by x is bigger or equal to 0, y is equal to 1 over 4x squared, y is equal to 2, and the y-axis. So what we're going to have here is so what we're going to have, so let's first look at 1 over 4 y squared, x squared. So y is equal to 1 over 4 x squared is like this, so 1 over 4 will just end up being like wider. Then after that we'll have our y is equals to 2 over here. Well, over here I'm just going to quickly write this. Okay, so back to this part over here, we also have our y-axis. So we supposedly have these two parts that can be bounded, right? But hold on a second. An x must be bigger or equal to 0. That means that we can only take the positive side for x, and we will just get this part. Why we cannot get the other part is because the x cannot be smaller than 0. So now that we have known what this is, we can find our boundaries. But before that, which one can we integrate first? Well, we can only integrate with respect to x first, because over here is cosine y cubed. Okay, so this over here, we're going to put this outside for a second. Okay, but first, what's our boundary? So since we are integrating with respect to x first, it will be from 0 to this function, 1 over 4. So 1 over 4 x squared is what y is equals to, right? So that means that x will be equals to 4y. So x will be equals to 4y. So x squared is equal to 4y. So x is equal to 2 square root y. Okay, so over here 0 to 2 square root y. Well, for y over here, it'll be from 0 to 2. And then for this part, we get straight away integrate for this, which will get a 1 over 4 outside, and then x to the power of 4. Then after that, we want to substitute this inside. When you substitute 0 inside, it just becomes 0, so you can ignore it. But if you substitute this part inside, you're going to get 2 to the power of 4 outside. And then you're also going to get y squared, because square root y to the power of 4 is y squared. Then cosine y cubed dy. And what we'll get now is, so first of all, you can simplify two of the 2's over here, which are, and then after that for this part over here, 20 over 3, because then you're going to put this inside. Why do we need to put this inside? So that we can integrate for this part over here, which we are going to end up with this. So it's going to be over here. So first we divide by 4, so this will just become 2 square, which times 5 becomes 20. And then you have to divide by 3, since over here we're going to put this inside this part. And now we can integrate this part, which we are going to end up with so cosine over here, what we're going to get, when you integrate it, it will become sine. So sine y cubed from 0 to 2. So sine 0 is 0, so we can ignore for that part. While on the other hand, sine 2 cubed will be simply sine 8. Well, you cannot get the result, so we just straight away put 8. So for our first example, we mainly just change from integrate from respect to x to integrate with respect to y first. Well, for our second one, we integrated it with respect to x first, since we cannot do the other. We cannot integrate with respect to y first, and that's mainly what we did for this lesson over here, which we have these two graphs. Okay. And that'll be all for this lesson. Last but not least, thank you for your watching.